As you've likely guessed by now, objects are not the only type in JavaScript that are taking advantage of prototypal inheritance. All of the other types are as well. This is why on our arrays, we have access to the filter method, and it's why on all of our strings, we have access to methods like includes. So in this one, we're going to analyze the prototype chain for all of those other types. We already went through the process once. It took quite some time, but going through it again is going to be much easier now that we know what we're looking for. To kick this video off, I actually want to start by defining a term, and I'm going to do that with a comment up on line 1. This is primitive value. A primitive value is a value that does not have properties. It is a non-object. There are 5 primitive values in JavaScript, all of which we've already learned a whole bunch about. We have string, we have number, we have Boolean, we have null, and we have undefined. We've seen all of these time and time again. Everything not in this list is an object. So what does that include? Well, obviously it includes objects, but it also includes other things we might not have expected, like arrays and functions. So what I want to do is start with those two. We're going to look at how arrays and functions use prototypal inheritance to allow us to access that shared set of functionality. Down below, what I'm going to do is remove all of the code we have so far. And right here, we are going to leave this comment in place. I'm just going to expand on it, saying that this is the prototype chain for an object. And then I'll make this variable a bit more generic, something like my object, and this will serve as documentation going forward. Next up, we're going to look at the array. So we might have something like my array. How is its prototype chain structured? Down below, we can go ahead and figure that out by creating a new array. Right here, const. I'll create an array for something like team. I'll create an array with 2 items, the first being the string Luke, teammate 1, and the second being Madison, teammate 2. Perfect. So we have our 2 players in the team, and all we're going to do is dump team to the console and see what happens. Console.log, team, printing it to the screen. Let's go ahead and save app.js, and over in the browser, we do get our array as expected. If we crack it open, we have 3 properties. We have the first item, Luke, the second one, Madison, stored by their index, and we have length. Under there, we have the proto property, which allows us to see that hidden chain. And if we expand it, what do we get? We get the array.prototype object. Here, we have access to all of the methods we've used before. We have things like filter. We have things like find index. We have things down below like for each, includes. All of them are listed here. This is why all of our arrays have access to that shared set of methods. So we can tweak this comment a little bit. Right here, we know that we have my array. After that, we have array.prototype. Just like object.prototype, this is something we can manipulate or change, though we're not going to. And just like object, there is also a constructor function we could use. But once again, we're never really going to do that. When we create arrays, we're going to be using the literal syntax. Now from here, array.prototype actually has a prototype, and it's not null. This is different than what we saw with object.prototype. We can prove this by scrolling down the list, all of the various methods and properties available to us, and at the very bottom, we have another proto property, and this one is for object. So right here, if we crack that open, we see everything we saw in the previous video when we explored object.prototype, including the method we used, has own property. Now we know that object.prototype does not have a prototype of its own, so we now have enough information to finish off this comment. Array.prototype links us up the prototype chain to object.prototype, and object.prototype links us to null. So when I say that an array is technically an object, this is what I'm talking about. The array is nothing more than a customized version of an object. Down below, we can prove this by accessing on our array has own property, something that we know is available on objects, but that we might not think is available on arrays. What we're going to check for is one of the properties we saw in the console. Let's check for length. If I save the file in its current state, we get true. An array does have that length property. If we check for something else like filter, we're going to get false. Do arrays have filter? Yes, they do, but they come from array.prototype. They are not on the array itself. There is also a constructor function for arrays. We can use that to generate an array, not using the literal syntax. That looks a little bit like this. New array, and then we just pass in our array. So I would pass in my 2 items inside of square brackets. I have Luke as the first one, and I'll have the string Madison as the second. Now, as I mentioned before, very rarely, basically never, are we going to use this syntax with a constructor function. When we create arrays, we're always going to use that literal syntax. Now we can move on to the next type that we're going to explore. That is the function. So let's go ahead and make a function and then dump it to the console. Const function, actually that's a reserved keyword, const get score equals a function. We can just create an arrow function, and we will use the shorthand syntax to just return a static number like the number 1. It does not matter what get score returns because we're never actually going to call it. Down below, all I'm going to do is console.log get score. Here I am printing the function itself. I am not calling the function. Now, if I go ahead and save app.js, we can see we have our function showing up, and on there we have a few different properties. We also have a proto property which links to function, and this is where we get access to all of the shared behavior from functions. There are some methods listed here that we will eventually explore in the course. This also has a proto property which links to object, and we know that object links to null. So here is the prototype chain for a function. We got a function, myfunc, it links to function dot prototype. That goes ahead and links to object dot prototype, and we know that that links to null. So when I say that arrays and functions are objects, this is what I'm talking about. Yes, they do have customized behavior that comes from array.prototype and function.prototype, but in the end of the day, both of them are just a modified version of an object. And now I want to turn our attention towards the primitives above. We've taken care of everything else. Up here, though, we have string number, boolean, null, and undefined. Now, there are 2 groups here. The first is null and undefined. These are truly primitive values. We will never access a property or method on them. But with string, number, and boolean, it's a little different because we know that we've definitely accessed properties on our strings. Just 2 videos ago, we learned about and used the split method to convert a string to an array. So how can I say that at the same time a string has a method but also is not an object? To explain this behavior, we're going to dive into an example. So down below, let's go ahead and make a regular string using the techniques we've explored, I think in literally the first code video, const. I'll call this one product, and I'll set it equal to some string. Let's use computer. Then all we're going to do is log it to the screen, console.log printing product. When I do this, what are we going to get? We get computer printing, but you're going to notice it is not something that I can expand. I can't look at all of its properties and the prototype chain because it is a non-object. It just has the value computer. But how do we explain the behavior of calling product.split and actually getting the correct results? If I save the file over in the browser, I do indeed get the array as expected, as opposed to some sort of error saying I'm trying to access a property on a primitive. What's happening here is that behind the scenes, when we access a property on our string, it converts it to an object. So strings, numbers, and booleans are indeed primitives, but they also have what's known as an object wrapper. This object wrapper is what gives it all of the functionality that we're seeing here. For example, the split method for a string. So let's take a look at exactly how that works. I'm going to remove the split call. Down below, we're going to create another string, const other product. This time, though, we're not going to create the string using the literal syntax. Instead, we're going to use new uppercase S string. This is the string constructor function. Right here, we pass in the value. Let's say for this one, we're selling a phone. Down below, all we're going to do is print it. Console.log other product. When I save things, what do we get over in the browser? We have our primitive computer up above. Down below, we have our string phone. This time we can expand it. We can look at all of its properties, all of the individual characters, and we can also look at its proto-prop, which is string. Now, string contains all of these string methods we've used before. If we scroll down, we can view all of them, including the one that we just used, split. It's defined right down here. So behind the scenes, when we try to access a method on a string primitive, it converts it into an object, it then calls the method on that, and it gives you the value back. In our code, we're never going to create a string using this technique. Instead, we'll just use the primitive value and we'll allow JavaScript to do the conversion for us. Now down below, if we continue to look at the proto property for our string, we have a proto property for this one, and this is an object. So this is why strings can be classified as objects as well. Now we can complete the little prototype chain for string. Right here, we have string. We start off with my string. We then end up going to string.prototype. Then we go to object.prototype, and finally, right here, we go to null. Excellent. So there we have it. We have our string prototype chain set up. For numbers and booleans, it is the exact same thing. We have that same conversion process happening behind the scenes. So right here, for number, we have my number. This goes ahead and gets the prototype from number.prototype. Then we have object.prototype. And then finally, we have null. And the last one we're going to add is for the Boolean right here, Boolean. We start off with my Boolean, the variable we create. We then go ahead and add Boolean dot prototype. Then, as always, we link over to object.prototype. And then finally, we link to null. So there we have it. This is the prototype chain for all of those internal types we've explored so far. This now explains exactly what happens when we access a method on a string, which otherwise wouldn't seem to be able to have a method defined on it. It gets implicitly converted to an object behind the scenes by JavaScript. It then calls that method, allowing us to do whatever we want, whether it's split up a string or see if a string contains another string inside of it. If you dig around the web long enough, looking at articles about prototypal inheritance, eventually you're going to hear someone say that everything in JavaScript is an object. They're kind of right, but not quite. There are primitive values, even though some of these primitive values do have object counterparts, but null and undefined will never end up being objects. So while it seems like most things in JavaScript are objects, it's not quite true. Now, it's also important to understand that what we're learning here is just describing what's going on behind the scenes. Because of the things we've learned in the last two videos, we're not going to be changing our code. We're not going to create strings differently or define our arrays using the constructor function. We're never going to modify object.prototype. All of these things are for exploratory purposes only. We now understand what's going on behind the scenes when we use various features of the language, and that's a super important thing to get a grasp on. I understand that this video and the last one were pretty dense, definitely the densest videos we've had so far, so give them a second viewing if you need to, and also don't forget, ask a question in the Q&A. There are also questions in there that already have answers. So if you don't want to wait to get an answer, you might not need to. There might be an answer sitting for you right in the question and answer section. All right, that's where we're going to stop for this one. In the next video, we're going to get back to the Hangman game, adding some new features in.